storyboard going. All right. This is it. Weather Center live at 9 a.m. in the morning, April 27th, 2024. We are live simultaneously on multiple platforms. Once again, we've got YouTube going right here. We've got TikTok off to my right-hand side. Good morning, ladies and gentlemen, from the TikTok weather sphere. Fantastic, Mia. Good morning. Good to see you. Ladies and gentlemen, we have a lot to talk about today. Again, just like my update yesterday afternoon, no semantics, no fun and games. As much as I love the attention grabbers and the hooks, for all intents and purposes, we're not going to do that. Yesterday was a very disastrous day for our folks across the Great Plains, and we're going to try to dig into the situation early today, regardless of the viewing platform, regardless of the view count, anything on the table. We're just going to go ahead and dig in. How close are we? Welcome in on the YouTube stream. We're getting closer on a positive note. We're getting closer to 10,000 followers on TikTok. So for those of you tuning in, I graciously thank you for your continued support. As we get closer to that threshold, eventually we will merge you guys with YouTube so we can go ahead and get all the information consolidated and put out to everybody. Because that's one thing. We have a lot of severe weather coverage, but I haven't seen too many people coming in and actually analyzing and giving you guys a breakdown of the day today. I feel disgusting right now because I was sipping pre-workout, getting ready to go to the gym, and I looked at Storm Prediction Center's charts, and after the crapshoot that was yesterday, I figured, you know what, we're going to lay off the weights for now, and we're going to get started with a live briefing. So for my TikTok folks, I'll turn you around as needed. Right now, we're going to give you a bit of a recap. So as of right now, preliminary counts have us around 100 tornado reports. Now, granted, take that with a bit of a grain of salt because a lot of those reports are probably going to be the same tornado reported by multiple spotters because we had a large count of long track funnels, particularly in eastern Nebraska that blew right through Omaha, the greater Omaha area. The western side of the city got it, the northwest side of the city got it, the more suburban areas got hit hard, and then followed up by a second, if not a third, supercellular storm that came in from the immediate south and blew right through these city limits. And then that intense activity continued on through Iowa. So again, this is why I mentioned in my updates again and again and again, regardless of the charts, regardless of this and that. Muhammad, I don't know who you are, but I'm declining. We have a lot to talk about today. I apologize. No one else is joining the streams right now. We're going to get into it, giving a recap on yesterday. Where the tracks of these low pressures are critical. You need to watch where the lows track. And I noticed in a lot of our preliminary model data that there were indications of a ton of extra vorticity, a ton of extra lift on the immediate east side of this low pressure. And that's exactly what ended up igniting. I felt terrible sharing it, but I even shared it in stories on YouTube, on TikTok, on Instagram, that from 7+ days ago, I'd been mentioning that Nebraska, Iowa, and South Dakota really need to watch. Thankfully, South Dakota was, for all intents and purposes, not really impact. They didn't see a whole lot from this. Nebraska, Iowa got it real bad. And we cannot forget about our folks in Texas, Oklahoma, and Kansas moving into the western periphery of Missouri because there was a lot of it that bled over as well. Please stop asking to join the lives. I don't know who you guys are. You're not going to join right now. I apologize. So as of right now, we're taking a look at the... I don't understand what's going on. There we go. Invitations turned off for my TikTok viewers. You guys can stay in the brief, but I don't know why I'm getting so many random invites to join. If you are somebody official or somebody willing to contribute, drop it in the chat and I'll consider it. But as of right now, I don't understand why I'm getting so many random invites to join the live stream. So as of right now, and I'll go ahead and turn the camera around for my TikTok viewers. Let me flip the camera and get you guys positioned so you can take a look at what we're seeing here. This is, let me see if I can fix this, figure it out. I have you guys on my stationary tripod stand. Once again, for my TikTok viewers, this is why I cannot wait to get to 10,000 followers. I don't know why TikTok has it to where you need 10,000 followers to get your stream key, and I can put you on the screen share and whatnot, but this is what we have going on. So Unfortunately, we've had quite a bit of dry air build in back behind our first system. Our first system is now centered right over the border of Minnesota and Wisconsin, and thankfully we don't have a tremendous amount of thunderstorm activity engulfed within its vortex currently. It looks like it's moving over, what is that, Lake Superior right now, getting ready to cross into the southern portions of Ontario, Canada. And then this here, this bad boy out to the left-hand side of your screen is what's coming in. And what has me concerned is you can already tell that there are multiple shortwave perturbations, or just little shortwave troughs, vortices embedded within this low. We have one here, we have one rotating around the backside, we have one firing across the front range of Colorado, getting ready to pass through southeastern Wyoming. And look at all this really good jet activity that's just digging across the desert southwest. They're dry right now in Arizona, New Mexico. And it actually looks like there's already some thunderstorm activity trying to ignite along the leading edge over the Texas-Oklahoma panhandle. So that's not good. And what I'm very, very concerned about, and I'll change the coloring of my pen here, is this extra dry air that's building back in behind our first low is going to help to evacuate the mid to upper levels of the environment of significant cloud cover. So as our return flow continues out of the south through Texas, Louisiana, Arkansas, Oklahoma, it's going to reestablish our area and prime it for more severe thunderstorm activity. And it looks like the threats are going to mainly be in very, very similar locations. A lot of our initiation is going to occur in Kansas, Oklahoma, the northern extent of Texas, and then move off towards the east-northeast. For my YouTube viewers, if you guys are watching, you notice the thumbnail has all those black arrows. I'm showing where initiation is likely to occur and the general environmental flow that's going to push them off towards the east and northeast. So we'll want to watch as this big old secondary low pressure organizes over the four corners and eventually ejects out into the central plains of Nebraska, Kansas. It looks like it's going to position itself somewhere right here again, which means our greatest severe threat is going to be just off to the south and just off to the east, extremely reminiscent of what we just saw yesterday. And like I said, my biggest concern is the fact that if we switch over to our visible satellite, as the sun comes up, notice we don't have a lot of high cloud. We have some low-level stratus. You can see there's low-level stratus through Texas, Oklahoma, and Kansas. We are likely very saturated in the low levels right now because of all the moisture that blew through yesterday. But that low cloud cover is going to burn off as the sun comes up. In fact, if you look through portions of Illinois, parts of the central and eastern areas of Missouri, I don't know if you guys can see on TikTok, it's very difficult. We're already starting to see that low-level cloud deck burn away. It's like kind of above-ground fog, if you will. Stratus clouds can go all the way down to the surface, and that's when you get your fog or your mist. Condensed stratus clouds just above the first maybe 100, 200 feet of the atmosphere is essentially lifted fog. That's exactly what happens with our air parcels as convective heating or daytime heating warms the moisture in the low level. That instability helps that stuff to lift. And that's why if you notice, when you wake up in the morning, you have dense fog in your area. After some time, the fog will start to lift. Let me switch you guys back so I can explain a little bit. After a while, the fog will start to lift, and that's exactly your convective initiation coming up. That's not literally thunderstorms forming, but that's the lift. That's the instability helping to rise that moisture up into the air. So I'm going to leave TikTok positioned on me because as of right now, we're going to get into more observed stuff. We're not going to talk forecast just yet. We're going to look and see exactly what's going to take place as you go over the next few hours. So as of right now, we're looking at a sounding for central Oklahoma. This is one of our areas where it does seem like we're going to see good convective initiation. And across the board, we have tons of stability in the low levels. We have huge caps, huge inversions because of that moisture that just is left over. We have hot air above cold air, which is good. However, as that cloud cover dissipates and we see that theta and that warm advection come back up from the south, that's going to change the game. And it's not going to take much to get rid of this inversion, especially since there really isn't a lot of subsidence or sinking air in the mid-levels to keep an elevated cap from bursting or keep an elevated cap on our thunderstorm activity. So once that radiation inversion is washed out completely through daytime heating and the sun coming up, that's when everything is going to kick off. We have a large discontinuity in our models right now, unfortunately. It seems like Some of our models are thinking we can have convective initiation as early as 1 to 3 p.m. Eastern Standard Time, so around lunchtime again yesterday to 2 p.m. CST. Other models, the NAM 3 kilometer did very well yesterday, and it looks like today the NAM is thinking we could have later initiation between 5 to 7 p.m. The HRRR is a happy medium, as is the FV3, which is a higher resolution model that caters to the GFS. The FV3 and the HRRR are somewhere smack dab between 2 to 4 p.m. in between our other heavy hitter high resolution models. So we're going to try to investigate as much as we can. If you look, this is a sounding for northern Texas, where we're actually expecting a huge swath of nocturnal stuff to blast through there. I think you guys are going to have a very, very prolific severe wind event down in Texas, especially as that southern periphery of the front and all that dry air and that cold air wrapping around the backside of our low can really get everything going. It's going to run head first into that return flow over central and eastern Texas, and everything's just going to get rushed up, and we're going to have very, very good mechanical lift. Basically, artificial lift provided by our low pressure in our surface front that's going to go crazy. So I think that Texas, you're going to have that isolated tornadic threat. However, if you look, I know you guys can't see it on TikTok. Bear with me. I see a lot of viewers dropping off because we're talking analysis, but this is critical. This is critical. You can't just go straight head first into the models. The models are going to let you down. They've been letting us down. Yesterday was a fine point. We had an enhanced that only expanded as things were going on. There was a huge bust yesterday. Storm Prediction Center, a lot of other entities out there just missed the mark entirely, and people paid for that. So that's why we're starting with analysis data first. We're not going to go into the models and start hyping this and focusing on that. Again, looking at northern Texas, we have a huge radiation inversion in place, almost like a pseudo-subsidence inversion down at the surface level, which means that your temperature and your dew point go away from each other. That would be considered subsidence. Radiation would be if your surface is colder than your upper levels. That prevents any kind of mixing. But as we get daytime heating, there's going to be some really good CAPE out there in Texas. And I also looked at some of the soundings in Oklahoma. I'll switch you guys over on TikTok as well so you guys can see. And I'll go ahead and draw it a little bit. Let me move you guys back just a little. Whoops, I didn't want to flip the camera. There we go. So I'm going to hold this. I apologize, YouTube viewers, right now. We don't have too many people tuning in on YouTube. They're probably waiting for all the Ryan Halls and the Reed Timmers and whatnot. But you know what? The Weather Center is going to do what he can. So this is your radiation inversion for my TikTok viewers who can see now. Notice how the surface is colder than the air just above it. As we get daytime heating and those low clouds we mentioned on the visible satellite burn off, what's going to happen is your temperature line at the surface is going to move this way. And the problem with that is, if you notice, we don't have a ton of dry air. We don't have a ton of warm air in the upper levels. We have a fairly decent lapse rate. It's not the steepest, but the problem with this is once we move our temperature line from the surface here to here and we uncap the surface, if you lift it, following the dry adiabat to the moist adiabat, eventually, wherever the CCL is, notice that we're going to have a pretty good line of instability CAPE. All that would be your CAPE. And take this with a grain of salt. I'm not physically calculating where our convective condensation level, our LFC is and all that. I'm just simply drawing it up following the adiabatic lines in the background here. So we have the ingredients for sure to give us another round of strong storms. And what I'm afraid of is if everything holds true, and I can even admit it, you know, the last few days, it definitely showed all signs pointed to this first storm being slightly weaker. I was still on board with very strong stuff happening in close proximity to our low with how everything was just wrapping back into the vortex. So that part verified, but I will definitely admit to you guys, there was some inaccuracies in what I was projecting to you because I didn't think we were going to see such an expansive, severe threat with it. We didn't have the ingredients for it, and I was too busy to really reevaluate if that had changed. So I dropped the ball, and I'm sorry about that. So today we're going to try to get ahead of it. So we have plenty of instability out there to play around with, whether it be in the low levels to the upper levels. And Carissa, there is a cap. There's a huge cap out there right now. We have a lot of good low deck stratus. We're very inverted. We're very cold at the surface because of all the rain and the thunderstorm activity we had yesterday. So the low levels are very capped off. We have a lot of SIN. In fact, the observed sounding we were just looking at in Texas has SIN upwards of 32,000 joules per kilogram, which is a huge radiation inversion. That just goes to show how much energy these storms had in them yesterday. Because what happens is when you have have your updrafts, that energy from the surface gets pulled into the top of the storm. And when you have your downdraft coming and raining out, all that energy has to drop back to the surface, and that's what leaves us with our overnight inversions. On top of that, the sun is not shining, so naturally the surface cools off. Land can irradiate heat a lot faster than ocean water can or water sources can, so that's why the surface of the earth will go up during the day and then really cool off. So desert areas are wonderful examples of that. Back when I was stationed in Tucson, Arizona, during the day we get up to 100, 115 degrees, but then overnight down to low 60s, upper 60s. Phenomenal cooling as the sun went down because the land can just irradiate all that heat back up. In this case, what I'm concerned about as well is I'm looking at our return flow. I'm looking at our Theta-E. I'll flip you guys around again for TikTok so you guys can see. We're going to do some closer examination. So this is what I swear by the Theta-E. I love the Theta-E. During synoptic meteorology, it taught me so much, and you can draw so many features just by looking at the Theta-E. Here's our first system. Here's a front. Here's our warm front moving up through there. Here's our secondary setup right in through here. Here's our new warm front that's establishing itself, and look at all this very, very gratuitous return flow. These thetas are dark. TikTok, I believe there's a filter on for some strange reason, and I don't know how to turn it off, and I don't want to sacrifice the live stream, so I'm not going to turn it off, but these values right in through here are very, very dark, and what that tells me is we have a stark contrast between our polar air that's coming down out of Canada. You can see it rushing in. Look at these wind barbs pointing due out of the north, rushing in towards the front range of the Rockies, Montana, Wyoming, Colorado. You have it sweeping in, and then it curls back through the desert southwest because our low is still developing back through here. But then look at this wonderful return flow that's just being pulled up by our linebacker here is what we'll call it. This first system is just allowing even more flow to get sucked up the Great Plains and up towards the Midwest, the lower Great Lakes. So, and this is analyzed. This is not whatchamacallit. This is not a forecast model. This is analysis. So this was yesterday, and look, you can see it perfectly. I'll rewind back to the main event of yesterday around 21Z. Look at how this is all curled up into our low. This is what I was afraid of. What this does and what that tells me is we have extreme converging wind flow down in the low levels that just allows these systems to ramp up tremendously. And of course, I'll switch the color of the ink because we're in such close proximity to our low. This is what's happening as you ascend to the atmosphere. So just nothing but rotation, 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 and that's what I'm afraid is going to happen again today. So I believe that our tornadic threat, based on what I'm seeing in terms of the models and where this system is going to patch itself up, is once again going to be in this general area. In that general area, and then down towards the south, depending on how strong our cold air advection can move in along the southern periphery of this low, that's where we're going to see a lot of ignition as well. But that'll be more so overnight as the cold air sweeps around the backside of the low and runs headfirst into all this modified air over the south. That's what's going to happen. It's going to rake it up for all intents and purposes. I see folks asking about Joplin, Missouri, Tulsa, Fulton, Missouri. I want to nail down locations, and we can try to do our best here over the next 10, 20 minutes, the last little bit of time that I have. I have Navy training I have to do immediately after this. This is probably going to be where your strongest stuff develops once again, and then this is going to be your secondary mode is what I'm going to call it down here, if you guys can see the yellow ink, because what's going to happen is our low and its embedded vorticity is going to ignite crap all through the central plains, and then I'll switch the color of the ink as our, that's not what I wanted to do. I'll switch the color of the ink, and as our cold air comes in along the back side and the south side of it, it's going to rake up all that activity and instability in Texas and Oklahoma, and I'll show you guys here in a second. As a matter of fact, we'll just shoot straight over there. Let's get into some of the model data. So this is our RRFS. And if you guys look, notice as we go through the day today, right about where we were predicting just a second ago, looking at our Theta-E, bam, there goes our convective initiation. Some strong storms right over Oklahoma, Kansas, moving into southeast Nebraska, unfortunately. And then see what's happening back here? See all that higher terrain snowfall? What's occurring is our low is deepening. So as our low deepens, vorticity and that jet activity is shooting out over the plains, helping to kick off some preliminary cells, and then we have cold air rushing in along the backside of it that's eventually going to emerge through eastern New Mexico into central Texas, and then notice how the model does a phenomenal job of showing that secondary line, boom, right there, popping off, and this is 7 Zulu. This is 2 a.m. in the morning Central Standard Time. And then, Lord willing, by then, we're already pretty mixed together. Everything is starting to become a lot less discrete and more quasi-linear, as we like to call it, more linear in fashion, and there's our low. There's our projected low system as we get into the day tomorrow. The one positive we have going for us here is the fact that this is going to happen as we go overnight. So we're going to have a lot less of that surface heating to take advantage of. We'll definitely want to watch the southern mode with this storm. I do think the southern half of it that's looking towards Texas, the southern periphery of Oklahoma, is going to be a secondary, more nocturnal mode. We're probably going to have strong thunderstorm initiation. We'll have to make satellite our best friend today. So if you guys on TikTok or you guys on YouTube are watching any other videos or any other content creators in the weather sphere and they are not closely watching visible satellite, nothing else. You don't need to look at SKUTs. You don't need to look at models. You don't need to look at X, Y, and Z. Just look at the visible satellite. The moment you see that low cloud, those little straticue that keep popping up as the sun comes up in that low-level stratus, that fog deck that has risen above ground level, once that washes away, you already know that those inversions I showed you on our observed soundings are going to start to warm. That temperature line is going to move in the right direction, and it's going to create a lot more instability in that SIN, that convective inhibition. The cap is going to erode away, and those parcels are going to lift, and they're going to lift fairly rapidly. So I think even without digging too heavily into a lot of the model data, I want to say that in Nebraska, southern Nebraska, Kansas, Oklahoma, the northern half of Oklahoma predominantly, depending on how widespread our low vorticity can let itself out. In fact, let's switch over to, I think I have it pulled up. Where's our 850 or our 500 millibar analysis? Okay. So let me switch you guys back over here on TikTok again. This is why I can't wait to unlock that stream key so I can stop doing this. But luckily, we're making do as we can. This is our observed vorticity at 500 millibars. So here's our first system that's moving off towards the northeast, getting ready to cross into Ontario, headed for James Bay in Canada over the upper Great Lakes. This X here is a vorticity maximum. And if you were to extrapolate this forward and follow the 500 millibar flow, it's going to travel just like this. So with these shortwave troughs, a wonderful little tidbit that they used to teach us in Air Force weather when we were training was divergence aloft ahead of a trough. And so what that tells me is, and I'll switch the ink color again, is we have our trough, our shortwave, our vorticity, so we have divergent flow and upward vertical motion out ahead of it. So if you extrapolate it forward using this track, and what extrapolation means is essentially if it keeps moving its current course, its current rate of speed, that's exactly where it's going to go. And right here, I'll draw it in a giant fashion. Right there is where you're going to see a lot of late afternoon activation, if not just a little earlier than that as well. So that's going to be your first mode is what we'll call it. And then as our cold air rushes in along the backside of it, supporting that shortwave, supporting our low and our frontogenesis down in the low first half of the levels of the atmosphere, that's what's going to create our secondary mode down here in Texas and Oklahoma. So I wish I had good news. The only bit of good news that I can provide for you guys right now is the fact that, like I said, a large majority of our significant, more scattered coverage looks to happen towards the back end of the day, which means that we're going to start losing our surface instability, our surface cape. That daytime heating that helps to really ramp up those updrafts is going to diminish ever so slightly. We're still going to have a lot of good synoptic scale forcing. And looking at the 850 millibar analysis for 11Z, this is a little old. I should probably refresh it, get our 12Z analysis up. You can already see excellent return flow and lots of good mid-level moisture surging through Texas, Oklahoma, up to Kansas. Pretty much outlines our Theta-E phenomenally. We don't have as much of a low-level jet established just yet. There are much stronger 850 millibar winds. I can see 50, 55-knot wind barbs, almost approaching 60-knot wind barbs through Illinois, Indiana, Michigan, the lower Great Lakes, parts of southeastern Wisconsin. But the problem is we are only at the start of the day. And with each jet with each finger of the jet, regardless of if it's 300 millibars, 200 millibars, 500 millibars, or 850 millibars, the reason our low-level jet has not increased just yet is because we don't have substantial temperature discontinuity. But what's going to happen is as our low develops over the upper four corners, Utah, Colorado, and move off to the east, it's going to bring down more cold air. It's going to increase the temperature gradient. in the vertical and the horizontal. If you were to look at a three-dimensional perspective of the Earth, the heart of the country from the Dakotas down towards Texas, that gradient is going to sharpen up, and that's what's going to help to increase the flow of the winds. It's basically like you ever wash your car with just a hose and you put your finger over the front of the hose to let the water shoot out fast. That's exactly what's going to happen. You're going to go from free-flowing, and you're going to put the thumb over the top of it, and it's just going to start accelerating. And that's exactly what happens to our winds, whether it be pressure-related, temperature-related, frontal system-related, low pressure, high pressure, etc., jet-related, all that. It's a lot of just the angular momentum of the Earth, and temperature-related, just temperature difference, is what creates these jets. So moving right along, we've looked at our vorticity. Here's our 500 millibar vorticity advection. I love the advection charts. We'll take a look. I'll show you guys on TikTok as well. I love the advection charts. We used to use a lot of this in Air Force weather as well. I think this does a much better job of that other than in comparison to that other chart, because it actually has wonderful colors for us to look at. And as we highlighted on our water vapor at the start of this briefing, notice all these little red blips. These are little embedded vortices. This is all your positive vorticity. And as we mentioned, looking at that previous 500 millibar vorticity and contour gradient chart is what it's called. This is going to be your steering flow in the upper levels. And this also, you can use just this. And if we switch back to our 850 millibar chart, let's go back right here. I'll put them side by side in the tabs. Go to the most recent analysis. This is where you get your directional shear in the upper level. So this is also what makes it a little more lethal for tornadic activity, because if predominantly we have a prevailing flow in the low to mid levels of the environment, almost due south out of the south-southeast, this is almost like an 80-degree component, not 80 degree, excuse me, 170 to a 180 degree component. And then off at the 500 millibar level, we have more of a, what is that? That would be about a 250 degree component. I'll go ahead and draw with different colors so you guys can see. So low levels of the environment, low to mid levels, we have a prevailing wind flow of this, which gives us our directional shear. I'll switch the color and we'll go over to 500 millibars. I'll leave that on there because this is exactly the same chart, same overlay. Notice how our 500 millibar winds are crossing like this. So there's your veering winds with height. So as those thunderstorms go up, they're going to encounter the different prevailing flows at each height level. So as it starts at the surface, the air parcel is moving one direction. As you get to 850, which is the first 3,000 to 6,000 feet of the atmosphere, give or take, depending on where you are, they're going to start to spin ever so slightly. You're going to develop that directional rotational component. And then at 500 millibars, when we're talking 10 to 15,000 feet up in the air, we're coming from a different direction, and that's what instigates the turning of the winds as they go up. And on top of that, speed shear. So right now at 500 millibars, we're in between jet maxes. Here's our jet max. Here's our jet max. Really strong winds coming in along the backside of this trough. Look upstream of it, as a matter of fact. We have wind barbs, and these are analyzed wind barbs between, what is that, about 75 to almost 90 knots of wind wrapping around the base of this trough. And as you extrapolate that forward, these winds have to go somewhere. So they're going to wrap around and move into the plane. So again, right here, I'll draw it in my yellow. I think once again, unfortunately to a lot of people, this is going to, no, I didn't want blue, I want yellow. Unfortunately to a lot of people, our greatest risk of strong storms, at least during the first portion of max heating of the day. After max heating has concluded, that is where a lot of your stuff is going to ignite. And then as we get cold air advection to sweep around the west and southwest side of this front or this low pressure system, the parent low, that's when this mode, all that leftover heat and moisture that is not doing much, just marinating over Texas, is what's going to get scooped up by that cold front and just blow up as we get into overnight tonight. And look at that. We really didn't see, this is what, and I'm not trying to, gloat or anything like that, but this is what forecasting is. If you can look at your analysis data and predict the weather without even looking at models, and you go to the models to do a sanity check and the models are more or less agreeing with what you're saying, that's a forecast. Anybody on here, on TikTok, on YouTube, Joe Schmo off the street could go and pull up Tropical Tidbits or College of DuPage and say, oh shoot, models are indicating 12Z, that's it. There it is, that's my forecast. It's like, no, that's the model's forecast. You didn't do anything. The computer model, you just read it to us. That's not a forecast. Just like I'm a little concerned about the fact that our HRRR and our NAM Nest are in huge discontinuity with, not HRRR, excuse me, our Rufus model, the RRFs, as I like to call it, are in very significant discontinuity with what is expected to happen. In fact, let's look at HRRR significant tornado parameters. And yeah, it looks like our STP parameters are highest as of right now in eastern Kansas, very, very westernmost Missouri, and central to eastern Oklahoma, and then overnight they start to go off in Texas. But I really don't think that Texas is going to have a significant threat for tornadoes. We're going to be too far to the south of a lot of our upper level dynamics. We're going to be more frontal in nature, so I do think there's going to be an isolated tornado threat for the central portion just to the immediate east of, if you draw a straight line. Like if you were to look at a map of Texas and draw a straight line from the eastern border of the Panhandle straight down to the border of Mexico, from that point on, you're going to have an isolated tornado risk, but I do think that our convective winds, our straight line winds, are going to be the number one risk with some hail mixed in there as well. Hail could be an issue even more so in Texas because of the fact that it'll be a little colder out. We'll be on the south side of this system, and a lot of those storms are going to activate as the daytime heating is beginning to go away. So our wet bulb zero, or our freezing line, is going to be a bit more optimal for that glaciation of our water droplets in the clouds. And obviously, hail is going to be an issue across the spectrum here because with so much cape and instability, those updrafts are going to be shooting up. All that moisture, that water is just going to be able to, I'll just say the terminology, collide and coalesce with one another and just impact, bounce off one another, really form up those ice crystals, and then they're going to mix around and come back down as probably multi-trip. And essentially what multi-trip hail is, for single trip, you have updraft, parcels go up, they ice, and then they fall down. Multi-trip, when you have very strong updrafts, what happens is your updraft brings those parcels up, the ice crystals glaciate, they freeze, but since your updraft is so strong, the updraft has enough pressure and momentum to keep those ice crystals suspended, and because you have more water rushing in at the bottom, I don't know why I'm bouncing, but as you have more moisture rushing in that updraft, fresh moisture, it just adds to the size of those hailstones as they cycle through, and then finally, as silly as it may sound, once they're heavy enough and the updraft just simply can't hold them up, they're going to fall. They're going to drop, and that's why you get the hail of 2, 3, 4 inches. Baseball, softball, gorilla hail is the new terminology that I've been hearing a lot after following a lot of the more recent storm chase videos on social media. So HRRR has our most significant tornado threat through Kansas and Oklahoma, trying to get into southeast Nebraska, western Missouri, and then Texas goes up overnight, but I don't think we're going to have as many ingredients as the models are hinting towards. See, the 3-kilometer NAM, I'm in far more agreement with. The 3-kilometer NAM makes a lot of sense. Oklahoma, Kansas, southeast Nebraska, northern Texas are going to be our greatest risk area, especially as we get towards max heating of the day. I'll flip the camera so you guys can see. Yesterday, the 3-kilometer NAM did the best out of all of our models, in my opinion, after rapidly glancing through and doing some initialization. This, just as we talked about on our analysis, like I said, sanity check. We're going to check the models after looking at our analysis data and notice that exactly where we had drawn before we even moved into models, like I said, is where our greatest tornadic risk is going to propose itself. So right now, everything's making sense. I'm making sense despite it being so early in the morning and my stomach being a little jacked up from drinking pre-workout and not lifting. The models are making sense, and the analysis data is going to make sense because it's actual live, raw data. Just to cover all of our bases, I really don't think we're going to realize a ton of activity as you move out of the plains. So as you get into the Mississippi, Ohio valleys, you're probably going to have some very, very sporadic severe weather. You're going to have very, very isolated instances where you get special weather stated storms, individualized cells producing 35, 45 mile an hour winds. You're going to have that penny, pea-sized hail, maybe nickel-sized, depending on how robust our storms can come together in Texas, that southern mode, and move towards Louisiana and Arkansas. Illinois, northwest side of the state, northern half, and especially the northwest quadrant of the state is going to probably be under the greatest threshold to realize some of this severe weather activity as that low propagates off towards the northeast, towards pretty much following the same path. This is a perfect example of why everybody thinks that the 2023 hurricane season was garbage, was just hype. Because we have low pressure after low pressure carving a path of least resistance for each of the upstream systems to follow. This is exactly what happened during last hurricane season. We had Hurricane Franklin move up the East Coast. Immediately followed by Hurricane Lee, followed his path, the wake of these storms. Lee followed the path. Nigel followed the path. Rena and Philippe followed the path. Tammy followed the path. That's why nothing managed to make it towards the United States, because they were at the right place at the right time to create. You guys ever go on a cruise or you go on a boat? And you look out the backside and you see all the water flooding back. You see that trail, the wake behind the boat. That's exactly what these weather systems do. They take up all that energy, they form their own little combustion engine like a car, and they move off, and that wake is what allows more storms to funnel in back behind it. It's the path of least resistance. It's like water. It floods in behind and then follows that same trail. And that's why I think this hurricane season is going to be different, because we already have big dominating features out there in the Atlantic. They're going to move them in a certain direction, and they're just going to follow suit, which is why a lot of our big names out there in tropical meteorology are thinking there's going to be a lot more westward tracking storms, and El Nino is not going to be in place to batter a lot of our steering currents over the northern and central Atlantic. This is a great example, looking at actual lower 48 data, why it is that these storms are just going to track and track in the same direction. And believe it or not, these lows, these frontal systems are actually helping to create different paths in our jet. That's why everything is just dead quiet down here in the mid-Atlantic, the Northeast, Florida. It's sunshine, it's hot. We're coming back into drought conditions here in Florida because it's been so dry. Because each of these frontal systems, the jet is in line with the temperature gradient from the surface all the way up to 200 millibars. And that's why they're just going to continue to track in this direction. And I don't think we're going to have a whole lot of wiggling and wobbling. Our first low that just passed through came out of Colorado, Wyoming, positioned itself over Kansas, Nebraska, moved right up through Iowa, unfortunately, and now is positioned along the border of western Wisconsin, eastern Minnesota, moving through Lake Superior and into Ontario. I bet you 10-1 this low is going to do exactly, if not very close to it, the same thing. And if there's a couple key takeaways I can give to you guys as we get ready to sign out of this forecast in the morning. Number one, satellite imagery. If you have the means of pulling up a visible satellite for your local area or just for the general area, and you see clouds starting to bubble like a pot of water, literally, that's exactly what's happening. You get that surface, like, to keep the metaphors going, you guys ever put a pot of water on the stove to boil some pasta or something like that, and you notice that as the water heats up, you start getting the little tiny bubbles at the bottom of the pot. Nothing up top is happening. You get that little steam, but there you go. The steam is that convective available potential energy. The steam starts to come up, and you get the bubbles at the bottom. Once that convective temperature in the atmosphere is reached, those bubbles rise to the top of your pot of water, and that's when you know, okay, it's time to dump my pasta in. It's exactly the same principle with weather, ladies and gentlemen. That's your crash course on how instability works. You slowly heat the surface, i.e. the bottom of the pot, and when the temperature reaches once the temperature reaches that optimal point, that's when everything will start to rise, and essentially the top of your water in your pot is the tropopause, the top of the atmosphere where weather phenomena can be realized. If you want to look at the way thunderstorms form, just take a random pot of water, put it on your stove, and turn the temperature up and just watch. That's literally, if you want to learn how CAPE works without a cap. I mean, obviously there's other dynamics. There's caps, there's synoptic forcing, there's a bunch of other mechanics, but if you just want the simplest demonstration that you could show your family and friends of how weather basically works, how thunderstorms form, put that pot of water, explain to them, as the surface of the pot, the bottom of the pot warms, eventually it's going to get hot enough and they're going to bubble up and reach to the top. That's your thunderstorm updraft. Thank you very much, ladies. No, I'm just kidding. No, we're not going to end. We are going to get ready to end the stream, but that's exactly what happens in your thunderstorms. And that's when you have other things like wind shear and different moisture content, or the moisture content at different levels of the atmosphere will help to interfere with certain things. That's in a perfect world. If we just had pots of water everywhere in the United States and the sun heated it up, we'd have thunderstorms every single day of the week. There'd be no point in time where there isn't any thunderstorms. That's in a perfect world. That's like just your most base example of it. That's why us as meteorologists and forecasters have to look at all the different pieces of the puzzle to determine, well, is the moisture there? you're not going to see any bubbling in your pot if you don't fill it with water. Is there enough shear or tilt to create tornadoes, strong updrafts, large hail? That would be, and I don't recommend this because obviously that water is going to give you third-degree burns, but that's where if you were to go like this and spin, or take like a bottle of water and spin it around like this, if you spin it fast enough, you're going to notice that your water continues to spin. That's why they say weather behaves like a fluid. Once you really can look at it and kind of imagine weather in a bottle like this, and just imagine it as a fluid, you heat it up, it's going to rise, you cool it down, ice cubes, they sink. You start to really understand the dynamics of the atmosphere, and you can start to forecast things. Then, of course, where the real science comes in is looking to determine if you're going to have enough heat to let those bubbles rise, if it's too cold and the ice cubes are going to sink or those bubbles are never going to go up, and so on and so forth. And there's a bunch of other parameters and dynamics, but that's like your basic meteorology. Mason, yes, we're going to have more tornadoes today. More tornadoes later on this afternoon, unfortunately, and right around pretty much the same areas that we saw them yesterday. So let's go ahead and rub, what the heck, David? Let's rub some people the wrong way by wrapping up the live stream, and let's take you through exactly what everything looks like for today. We're going to use the NAM nest since we're already here. We can adjust on the fly as need be, but this is where we're starting right now. This is live here. This is, 9:41 Eastern Standard Time, so we'll start at 10 a.m. Eastern Standard Time, and as we go through the day, the NAM thinks we're going to have a later initiation, and I bet you it's probably because of all this down here. We'd have to take a look at our radar right now to see if that's actually out there. If that stuff is out there, then we might see a delay in our thunderstorm activity. If it's not out there, then I would not be surprised if we see earlier thunderstorm development. Once Radar Omega is done loading up, we'll turn on our composite and take a look. So, yeah, so the NAM, once again, is doing okay. Because look at this. We already have some stuff bubbling up over Texas right along this little embedded trough. So the NAM is already doing okay for itself. We've got some initiation out there. Looks like Pueblo, Colorado. Dang, I'm very familiar with Pueblo, Colorado Springs, the Boulder, Denver area to the north as well. Looks like we have some pretty good thunderstorm activity, straight line thunderstorm activity occurring out there. We have a special weather statement that expires very soon. Central Iowa is going to have to watch. The only positive side that we have, I guess you can call it a positive side, is it'll be happening a little bit later than it did yesterday. What's really going to determine what happens in Iowa, because here's your low. You can see it's spinning. You can already see a very broad area of low pressure spinning there, and if you extrapolate it forward, it's going to move like this, more or less. It's going to follow the wake of this mature wave that's up here. And so as that builds in, as this boundary can start to collect and pool hot air and moisture, I would imagine that wherever this line is, this stationary tail, wherever this line is coupled with the track of this low, you could more or less make a case that your strongest activity is going to occur right around that same general area, right through there and just sweep in. And, of course, I drop it here as we move through Iowa into Wisconsin and Minnesota because we're going into the extreme overnight hours of, sundown, early morning hours, nocturnal time, well after sunset. And so as a result, what's going to end up happening is you're going to cool down and we're going to lose that instability, that you're going to turn the stove off. Let's put it that way. So same areas. That would be my preliminary forecast. Same areas. Colorado's already getting some pretty good stuff. We probably have higher terrain snowfall in Wyoming, Idaho, Utah. And as that low emerges, what's going to end up happening is you're going to have the same type of activity fire over North Texas, Oklahoma, Kansas, and it's just going to sweep off towards the northeast. Wichita, you're going to have to watch very closely this afternoon. Ohio, no, Drew, you're going to be just fine in Ohio. Ohio, Indiana, Michigan, even the eastern half of Illinois. I'd say Illinois is still in the danger zone in terms of looking at some severe thunderstorms. Tornadic threat is going to be low. You could have a spin up because of the dynamics in play. As that low-level jet increases, you're going to increase that fire hose effect we talked about earlier. And but same general area. If your area or close to your area was affected yesterday, definitely be on guard. You need to have your defense ready to rock and roll. Make sure you can slip the jabs and weave the rounds. Is today going to be bad than yesterday? It's going to have a chance to get as bad as yesterday. Hopefully not, because we will have a couple of the dynamics that were left behind in the wake of our first system working against us. But it's going to have it's not going to be worse. Mark my words, Lord. It's not going to be worse than yesterday. It has the potential to be on par, and we might have a bit more scattered coverage. Because if you guys recall yesterday, we had pockets. We had really bad stuff in Nebraska, Iowa. We had really bad stuff in a very small pocket of Kansas. We had really bad stuff close to Fort Worth, Austin, Killeen, Texas, and then eastern Oklahoma trying to get into Arkansas. We had very small little pockets. Today, I think we have a greater chance to see it more widespread, more blanket protection. So that would be my best guess. We'll have to start watching now because we already have some thunderstorms igniting, which is a little alarming. That goes to show that our cap is already trying to remove itself from the equation. We have some activity starting to go in Texas Panhandle headed towards western Oklahoma, and then from here on in, it's all downhill. We'll have to pay attention to what develops towards central Kansas, the southern border of Nebraska. And remember, guys, visible satellite. Look at your fronts and look at the radar. So, and that's it. That's all I got for you. Indiana should be okay today. We're not really going to see too much. Indiana, all the other areas that are very familiar with severe weather that have been going on for the last several weeks, the last couple of months now almost, you guys are taking a break, and Tornado Alley is what's really going to be lighting up as the terminology goes. Southern Nebraska, it could happen anywhere between 2 to 6 p.m. So hottest part of the day, Central Standard Time, is going to be between 11 a.m. to 1 p.m. That's when you're turning the stove on and your water's starting to boil. When it comes to a boil is usually around 2 to 6 p.m., depending on your cloud cover, depending on if there's a lot of rain, depending on if you're starting out colder. In this case, we are starting out a little colder, so it could be somewhat later in the day. And from then on in, it's all downhill, and we'll just have to ride it out like we did yesterday. And it pisses me off that I'm here in Florida talking all this crap, and I can't actually be out there assisting. That's what gets me so frustrated about not being able to do this. I got to be careful. Not being able to do this professionally is, I am, but obviously I can't travel, and I don't have the means of getting out there and assisting folks. Because yesterday's damage was really bad. Really bad. Easily looked like F4 damage looking at some of the videos that I'd seen. No homes completely swept from their foundation, but obviously we're looking more at the variables of wind speeds and damage as opposed to just damage. So I don't know if we're going to have anything rated F5. I definitely can see F3, F4 across the spectrum, though. So Iowa, it's going to be later in the day. Iowa, you're looking at an evening threat. Just like yes, it's going to be basically a rerun of yesterday, maybe an hour or so either direction. It could be an hour earlier for our folks in the plains. Could be an hour to an hour later for Iowa, Wisconsin, Illinois, Missouri, because everything's going to be coming out of the Central Rockies, posturing itself and really getting going over Nebraska, Kansas, and Oklahoma, and then it's going to continue to move off towards the northeast. So we can track this stuff forward. It's just a matter of watching when it initiates. And I hate to say it, folks, but I do have to get going. It's 9:48. I got training I got to do, and then going to a wedding today. So I got to get ready for that. And we will definitely update you later on this afternoon, early evening time, just as we always do. That's why I wanted to come live, because I was thinking of posting, but I know a lot of folks on TikTok, they'll just scroll, watch for like 3 seconds, and then scroll. So I figured a live discussion for folks who want to tune in. You can stick around and ask questions and get interactive. So we will update you later on today with an actual post. Thank you all very much for watching. We have a nice little viewing platform on YouTube now. Very good. We have a nice little concurrent view base. I think weather creators with a huge reach need to buckle down a little bit and start doing more of these early outlooks. This is exactly what's going to happen the rest of severe season. This is exactly what's going to happen during the hurricane season. As we build a little bit more momentum, and hopefully we hit 10,000 followers on TikTok and we can merge the chats, I can show you guys everything in a put-together consolidated briefing. We can start doing this even more so, because sometimes that's why I don't stream on TikTok. I'm sorry, guys. The reason I don't is because it's very rudimentary. I have to put a camera on I have to put my phone on a tripod and hold it, and then YouTube has to be on the back burner for, here I go with the bouncing again. That's my simulation of doing a live stream. YouTube has to be on the back burner, and then I switch gears, then TikTok is on hold, then I come back to TikTok, YouTube's on hold, and I can't wait to blur it together. So I promise, God is my witness, I'm not going for the clout, I'm not going for the hype, I'm not going to be known. I'm literally just preaching 10,000 followers, because that's TikTok's threshold for us to get our stream key and be able to put you on OBS like my YouTube viewers. Whoops, there goes my tripod dying. As I said, very rudimentary. That's what TikTok requires for us to be able to put you on with YouTube and everybody into a consolidated chat so that I can answer everybody's question. That is the number one reason. I can guarantee you, promise you, it is not just for the sake of looking good or looking for the views or anything like that. I really, really, really want to merge the chats so that I can give you guys even better quality briefings, as opposed to talking to TikTok, talking to YouTube, talking to TikTok, talking to YouTube, talking to TikTok, and so on and so forth. Fort Worth, more than likely going to get hit. More than likely going to get hit. How bad remains to be seen, and I do think that Fort Worth is going to be more of an overnight or early evening event. And you guys can track it forward as well. There's going to be a lot of streamers on there with even greater followings than I do, and they're going to have it live, hour by hour, minute by minute. Unfortunately, I can't provide it. Sadly, I just have too much going on today, and it'd be a big struggle to go between YouTube and TikTok. But you guys can do what's called extrapolate it forward. Once you start seeing stuff firing on the west side of your Great Plains states, Kansas, Oklahoma, the Texas Panhandle, it's only going to move in one direction, and that's east. So you can track it. And all these other folks, Reed Timmer, Ryan Hall, Evan, TRG, there's a bunch of people on YouTube, TikTok, social media alike. They're all going to be following it throughout the day today, and they're going to have your back for sure. If you're talking Wichita, Kansas, he said we're going to get hit to just really watch. Yes. I know that sounds very, and forgive me, I know that sounds very just broad-brushed, like, I just watch. Everybody says just watch, but when I say that, I truly mean, a lot of us can't stay right here and watch the development of thunderstorms and then notify you at a moment's notice. I wish we had those capabilities. We're not quite there yet, but you'll have to we like to say in the military, maintain your situational awareness. Just keep your head on a swivel. When you start seeing dark clouds, it's safe to say it's coming. When you start to feel the winds pick up, you'll know, like, things are moving. There's a reason there's wind. There's always a reason there's wind. It's not just windy. There's a reason. And when you have thunderstorms like this blossoming, it's because there's dynamics in motion. There's feeding of the thunderstorm. There's outflow from the thunderstorm. There's downdraft from the thunderstorm. There's rain falling somewhere, and that energy is reaching your area. Jillian, I salute you guys. Very good to hear, military family. That's awesome. So yeah, guys, definitely got to go ahead and quit the streams. I definitely wanted to get in here and brief you all, though, especially. And if you want, folks on YouTube, folks on TikTok, if you want to move over to my YouTube channel, this live stream that I'm streaming is going to post to the channel. So if you want to rewatch it or fast forward and get to your selected pieces that are more pertinent to you, feel free to do so. I want to avoid yesterday today. I want to avoid yesterday today. Yesterday was a very, very disastrous day. It was, for all intents and purposes, a disaster. A natural disaster to the textbook definition, and whatever it takes, my small reach here, if it affects and it reaches the few hundred on TikTok, the few hundred on YouTube, that's enough for me to feel like I did my part. I'm trying my best. And that's exactly what a lot of us are doing. So, lots more to come, but we'll talk to you all very soon. Thank you very much on my YouTube viewers for staying in the chat, hanging out with us. Just to kind of recap for people who may be tuning in and asking, Nebraska, again, Kansas, Oklahoma, Texas. For the Plains, you guys are going to have your mid to late in the day activity at your worst. Minnesota, southern half, maybe. Wisconsin, maybe. Iowa, northern Missouri, your guys are going to be later into the evening. That's when you guys are going to get it. But Nebraska, Kansas, Oklahoma, Texas, Iowa, Missouri, Arkansas might be more of the overnight mode. Louisiana might be more of the overnight mode if they can move off to the east far enough. But my Great Plains states, Nebraska, Kansas, Oklahoma, big time. And then Missouri, Iowa, it's going to funnel down. It's going to shrink as we go overnight. So that's kind of like our backwards cone of uncertainty, as they would say in National Hurricane Center. So those are going to be your states. If you live in any of those states, just keep your head on a swivel and maintain that situational awareness, and you're going to be okay. You're definitely going to be okay. I always say, and obviously it's shallow to some who have been directly impacted, but I'd much rather replace assets than replace flesh and blood. You can't replace flesh and blood. There's no means of doing that. So as long as you can protect your loved ones, get the word out to those you know and care about who may be in the direct path of some of these thunderstorms, some of these tornadic thunderstorms, you're doing the work of heroes. So that's what we're trying to do here. So I wish I had more for you guys. I wish I had more time. So South Missouri here, what's happening? South Missouri, you're not gonna have to watch too heavily. Might be some sneaky thunderstorms as we get towards the late night, early morning hours, and but projected path is going to be Oklahoma, Kansas, southern border of Nebraska. We'll have to watch where that front wiggles and wobbles. If it makes its way further to the north, you can best believe your thunderstorms are going to move further to the north. And then again, the big thing is watching the track of that low. A lot of folks don't say that enough, too. The low itself, there's a reason it's spinning. The low in of itself is a huge area of energy and instability. That's where you get your mechanical lift. You're not just daytime heating lift, you get your enhancement. And that's why we had such bad tornadic activity in close proximity to that low yesterday, because you had a wonderful environment out ahead of it, and then your low was rapidly deepening and strengthening, so that just created all kinds of turbulence in the atmosphere, and it just accelerated the strength of our tornadoes and our storms. And we don't want a rerun of that today. So watch the fronts, watch satellite, and hook on to a reliable weather source and hold on. That's literally all. It's truthfully all you can do. You have to respect Mother Nature. You have to respect the wind, as they used to say in Twister back in the day. So thank you all very much for watching on YouTube. Thank you very much for those of you on TikTok. I genuinely appreciate you guys. And we will be updating you throughout the day, either via stories or by a hard post later on this afternoon, early evening time. I will make it a point. I don't care if I have to stand there at the wedding and shoot like this and talk weather. I will definitely post for you guys. It's going to come out. And we'll be in touch. You guys are going to be okay. You guys are all in my thoughts, and my prayers sincerely mean that. Work day and night to study up on this material so I can get you guys the best message that I can, especially when others are not available to do so. And we're going to be okay. Just remember that. Everything's going to be just fine. It's like a roller coaster. You know, the worst buildup is waiting in the line. And then once you're on the ride, it's fast and it'll be over before you know it. And that's how we have to look at this. Right now, we're all standing in the queue, waiting in that hour, 20-minute line at Busch Gardens, at SeaWorld, Universal Studios, Six Flags, whatever your theme park of choice is. We're all waiting in the queue, waiting to see what happens on the ride. And then once we're on the roller coaster, it might have some experience, it might have some twists and turns, barrel rolls, loop-de-loops, but then we're gonna get through it. Then we're gonna get off. That's the number one thing. As long as we get off the ride, that's what matters most. All right. Iowa is going to be a threat zone for today. Kansas, Nebraska, Oklahoma, Texas, threat zones. Iowa, southern Minnesota, maybe getting into Wisconsin since this storm will be a little bit stronger. It might self-sustain a little bit longer. That's your threat zone. Central Plains, upper southern plains is how we'll describe it, and then northeast. It's going to come out of the Rockies and track like this, just like that. And as your daytime heating is lost, that threat zone near your low pressure is going to shrink, and then we have our southern mode as the cold air comes out of the southern Rockies and goes through Texas and Oklahoma. We'll probably have a resurgence as the sun goes down. But all right, guys, we'll talk to you very soon. I do have to go ahead and cut it immediately. Apologies for the abrupt conclusion. It is 10 o'clock. For my YouTube viewers, this is Weather Center Nazario signing out. So again, for my TikTok viewers, now that I ended